All right, ladies and gents, we're going to talk today. This is part 1 of 10.3. All right, on Monday, we're going to go over the process of Gaussian elimination. All right, it's just a bunch of algebra together, that sort of a thing. But instead of 2 equations with 2 variables, we're going to be talking about 3 equations with 3 variables. So your answer is going to be in something called an ordered triple instead of an ordered pair. So you're going to have an x, a y, and now a z value. So your ordered pair would be xy. So this is just going to be xyz. All right, so there's going to be 2 types of questions with this part 1 that you're going to be asked. One is the ordered triple a solution? And 2, you're going to use what's called back substitution. We'll talk about that in a second. Now, here's the trick with this, guys. Right, you're going to be given an ordered triple. So this is your x value, this is your y, and this is your z. These 3 numbers have to satisfy all 3 equations. If it works in 2, don't just assume it works in the last one, okay? You have to make sure it works in all 3. So the way that you would show me this, what we would do is we would say, okay, 3 times, I'm going to plug in 3, minus 5 plus a negative 3 equals 1. So just go ahead and simplify. 3 times 3 is 9, minus 5 minus 3 equals 1. What's 9 minus 5? 4. What's 4 minus 3? So 1 equals 1. So then you can say, oh, okay, good, it works in the first one. Now we're going to say, okay, let's try the second one. Now notice, guys, there's only 2 variables in the second one. So you're going to substitute in for the x and for the z. Pay attention to what you're doing. So this is 2 times x is 3. Minus 3 times z is negative 3 equals negative 14. What's 2 times 3? 6. Negative 3 times negative 3 is what? So 6 plus 9 equals negative 14. What's 6 plus 9? 15. Does 15 equal negative 14? No. So right there you can stop and you can answer this question and say no. It says determine if the ordered triple is a solution. No, this is not a solution because it doesn't satisfy all 3 equations. As soon as you get one that doesn't work, you can stop and say, oh yeah, no. But the way that you guys show me that is by plugging it in and showing me, oh look, the left-hand side does equal the right-hand side, or vice versa. It doesn't. Does that make sense? All right, so let's look at number 2. Again, negative 1, 0, and 4. So I'm going to plug in. I have 3 times negative 1. Minus 0 plus 4, does that equal 1? Okay, so 3 times negative 1 is negative 3. Minus 0 plus 4, does that equal 1? Negative 3 minus 0 is just negative 3, yeah? Plus 4 is 1. So does 1 equal 1? Yes. All right, try the second one. 2x minus 3z. So 2 times negative 1 minus 3 times 4, does that equal negative 14? 2 times negative 1 is negative 2 minus 12. Negative 14 equals what? Negative 14. So that works. So can we just assume, I'm sure the last one's going to work. No. You've got to make sure. You have to show me that. So now it's 5y plus 2z. So 5 times 0 is y plus 2 times 4. Does that equal 8? What's 5 times 0? 0 plus 8 equals 8. Does 8 equal 8? Yes, it does. So is this ordered triple a solution? Yes. All right, it's pretty basic. Let's look again. What's the equation? 3x minus y. So 3 times 0 minus a negative 1 plus 1. Plus 3, I'm sorry, equals 1. Did I write it right? 3x minus y plus, yeah. So 3 times 0 is 0. What's negative 1? 1. 1 plus 3 equals 1. Does 4 equal 1? No. So what's your answer here? Nope. It's not a solution. 1, 0, 4. Okay, so 3... Help me out so I don't make the video go crazy. 3 times 1, is it minus 0 plus 4 equals 1? Minus 1 plus c. Okay, so I got it right, correct? Yeah. Okay, so 3 times 1 is 3. Minus 0 plus 4 equals 1. What's 3 minus 0? 3 plus 4. Does 7 equal 1? No. So does this one work? No. You have to plug in. As soon as 1 doesn't work, you can stop. Because your ordered triple should satisfy every single equation in the group that's given to you. So on WebAssign, when it says, is this a solution or does the ordered triple satisfy, that's how you guys would show me. It's very basic, but that's how you would show me. Does that make sense? Okay, let's move to the one. This is called back substitution. Okay, the way that these equations are written, we're going to talk more about this on Monday, but write this down. This is called row echelon form. It's referred to as kind of like stair steps. Do you notice how the first equation has how many variables? 3. Then the second one has how many? Then the last one has how many? 1. So what we're going to do is you guys are going to start with 3 equations, 3 variables. And you are going, on Monday, we're going to work them down to where they are in row echelon form, where it looks like this. First equation has 3, second equation has 2, third equation has 1. Then you're going to use back substitution. So we're going to talk today about what back substitution is. And then Monday, we're going to talk about going from the big problem to this. How would you solve this? There's not anybody in here who could not solve this, even though I haven't taught this before. What would you do here? Okay, I know what z equals. So where could I put z to figure out another letter? Right? Couldn't I go right here and say, okay, well, y plus 2 times 9 equals 9. Y plus 18 equals 9. What do I do to both sides? Subtract 18. And y equals what? Negative 9. Okay, so now I know that y equals negative 9. Is there a way that I could now figure out what x equals? Yes, I could take this y and put it there, and I could take this z and put it there, right? Do you see how you're working backwards? That's why it's called back substitution. So I'm going to say, okay, fine, x minus y, so minus negative 9, plus 5 times 9 equals 41. So x minus a negative is plus, so x plus 9 plus 45 equals 41. What's 9 plus 45? 54. So x plus 54 equals 41. Subtract 54 from both sides. What does x equal? How much? Negative 13? Negative 13. Okay, so you need to write your answers, guys, as what's called an ordered triple. Because does the order matter? Yeah, absolutely. So what is my ordered triple here? Negative 13, negative 9, positive 9. You're going to write it in ABC order, X, Y, Z. Now, what's something you could do to just make sure that it works? You can plug it back in, yeah. You go back into the original, that's fine. Does that make sense? All right, so let's look at number, what do I have, 6? Okay. What do I have to do first here before I just start plugging in? Do I have z all by itself? No, I have negative z. I wanted to just say z, so what do I need to do? Divide by negative 1, good. Because signs are real important, guys. So z equals 1, all right? That's good, we have that. Now what do I do to figure out what y is? I'm going to plug it in right there. So I have 2y plus 8 times 1 equals 8. 2y plus 8 equals 8. What do? Subtract 8 from both sides. I get 2y equals 0. Oh no, did I do something wrong? No. Divide both sides by 2. And y equals what? Is that an okay answer? Yeah, for sure. Y equals 0 is an okay answer. Fractions are okay answers. That might happen. So now in order to find what x equals, we're going to take this z and plug it in right there. We're going to take this y, plug it in right there, and find out what x is. So 4x minus 3 times 0 plus 15 times 1 equals 3. What's negative 3 times 0? So plus 15, good, equals 3. Now what? Good, minus 15 from both sides. So 4x equals negative 12, and then divide by 4, and x equals negative 3. So how do I write my ordered triple? Negative 3, comma 0, comma 1. Perfect. Is this crazy hard? No. That's why we did this today. 2 more, and then we're done. All right, let's work backwards here. I know what z equals. Awesome, let's stick it in right there. So y plus 2 times 2 equals 2. Y plus 4 equals 2. Subtract 4 from both sides. What does y equal? Y equals negative 2. Guys, signs are so important. There's a huge difference between 2 and negative 2. If you plug in 2 when it should have been negative 2, it's going to mess up your answer. So just make sure you're paying attention to all of your signs. So I'm going to take this z, plug it in there. I'm going to take this y, plug it in there to find x. So 2x minus a negative 2 plus 5 times 2 equals 16. 2x minus the negative gives me plus 2 plus 10 equals 16. 2x plus what? 12 equals 16. Minus 12 from both sides. 2x equals 4. And then x equals what? Yep. So how do you write your ordered triple? Wait, say it again.
4 negative 2.
What? 4 divided, right? So 4 divided by 2 is 2. Negative 2, positive 2. There's lots of 2's there, and that's okay. All right, let's look at the last one. Do I have z completely by itself? No, it's close, but I have to get it all by itself, so I'm going to divide both sides by negative 1. So z equals negative 2. Take that z, plug it in right there. So 6y minus 5 times negative 2 equals negative 8. 6y equals, just kidding, 6y plus 10, right, equals negative 8. So what do I do to both sides? Subtract the 10. So 6y equals negative 18. Divide both sides by 6. And y equals negative 3. Perfect. Last thing I need to do is find out what x equals. So I have my 4x minus 3. What was my y value? Negative 3. Minus 2 times, what was my z value? Negative 2. Does that all equal 21? So 4x. Negative 3 times 3 is plus 3. Negative 2 times negative 2 is plus 4 equals 21. What's 9 plus 4? 13. Okay, so 4x plus 13 equals 21. Now what? Subtract the 13. So 4x equals, what's 21 minus 13? 8. Divide both sides by 4. And x equals what? 2. So what is your ordered triple? 2, negative 3, negative 2. Perfect. Good job. Questions? All right, this is really, really easy. It's just a matter of paying attention to what you're doing and not making careless mistakes. Because little things like, oops, I meant negative 3 and I put positive, it makes a really big difference when you're plugging into other equations. So just make sure you guys are paying attention to that.